Standard 9.2 meets asks if you can calculate the frequency, period, and amplitude and/or wave speed of an object in a lab setting or graph. So taking a look at this, we are clearly looking at a graph. You could obtain this graph from a lab setting. A problem that was based on a lab setting would probably give you a little bit of a description of what the people in the lab were finding, and then you would need to determine information from there. So in order to be successful in that situation, you need to know what the definition of each of the words on this screen is. And to be successful in this situation, you need to know the same things. So first, let's talk about our equations. In order for us to find period, we know that period is 1 over frequency. We know that frequency is 1 over period. And we know that amplitude is equal to 1/2 the high point minus the low point. We can find all of these things on this graph and from the information that we have. We can't find the wave speed here, but I do want to just talk about the wave equation quickly for you. So V is equal to frequency times wavelength. So we have no way to really determine the wavelength here. We do have a way to determine the frequency, and we're going to do that down here. Because we don't know the wavelength, we can't calculate the speed, but if you did have that information, calculating the speed is pretty simple. You're just multiplying your frequency times your wavelength. Let's start by solving for period. So period means the amount of time it takes to complete one cycle. If we look at our graph and we follow this path, that's one cycle from where you start, right, back to where you start after completing an entire cycle. So we need to have an entire crest and an entire trough in order to have a period. Looking at our time in seconds, it's clear to us that our period is 40 seconds. Our frequency equation is 1 over t, so 1 over 40, and our unit here is hertz, abbreviated Hz. Last but not least, we have our amplitude. We see that we're reaching a height of 0.5 meters, and we're seeing that the bottom part, our trough there, is reaching 0.5 meters as well. So we can use our equation, and we can take A is equal to 1/2, our high point is 0.5 meters, minus a negative 0.5 meters. We end up getting A is equal to 1/2. So if we have 0.5, minusing a negative is the same as adding. And so we could get that our amplitude is equal to 1/2 times 1 meter, which is 0.5 meters. Or if you didn't want to do that math, you can also understand that the distance from equilibrium, or the center, to the crest, or from equilibrium to the trough, is going to be your amplitude. So we could take a look at our graph here and see that from 0 to the top point or 0 to the lowest point is 0.5 meters. We would get the same answer that we got using the equation.